Sorts of fun stuff. This was us doing like decibels intensity earlier with another student a couple days ago. I want to say this was Odin's question, right? Odin, if you're in the chat, I wonder how his test went. So let's see. We got a couple fun ones that I already have up here. Bobby the Goat got a good question here. Bobby, if you're in the chat, just let me know. We'll go over it. But yeah, again, this is kind of the information for the stream tomorrow with Zach. We're going to go over the use of mathematics and physics. If you have any questions you want to submit ahead of time, please feel free to, you can put them in his channel. I'll also make an announcement in our Discord tonight showing where you can kind of dump some questions ahead of time. It's fun to just like seed the pot, you know, with some topics. I can talk forever about anything anyways, but it's much more useful if it's helping you guys out with what you want to know. All right, so this was a question that came from Psyduck. And then we have one from Bobby the Goat. When Bobby shows up, I'll do this. This was kind of another cool one that came up. All right, let me make sure my chat's working on all platforms. Right, we have a lot of platforms that this works on. This is the one I want. All right. Select live source. Make sure that's good. Great. And then let's get TikTok running. Sometimes takes a little bit. Bum, bum, bum. Someone commenting on my video saying if you understand phase shifts, it's so much easier. Duh. But phase shifts suck. Not many students understand how to do a phase shift with sinusoidals. That stuff happens all the time. All right, let's see. Yeah, so if Bobby shows up, I'll do this one. Let me see this one. This one's from Psyduck. Got submitted earlier. And it says, okay, let x equal 4 divided by this huge mess. Find x plus 1 to the 48. Fascinating. Okay. It's kind of an interesting one. I wonder how we're going to do this. Okay. I agree with that. Yeah, you're the one. I agree. Let's do that. That's a very good first start. Let's do that, Jeff. Right. So Jeff brings up a really good point here. So what I see already to start with, if we were to write out these radicals as exponentials, okay? The good way to do this is anytime you have, like, let's say the square root, and not the square root, let's say it's the bth root of x to the a. This is the same thing as x to the a divided by b. This is called, I believe they call it rational exponents. I call them like fractional exponents. I know it's technically like not the correct math term for this, but so this is the key bit of information here. So what I see here is this is the same thing as the 16th root of 5. So I can say this is like 5 to the 1/16th plus 1. This is the same thing as 5 to the 1/8th plus 1, right? And then this is 5 to the 1/4 plus 1. And then this is 5 to the 1/2. All plus 1. Okay. Another interesting thing to note here is that there seems to be a pattern here, right? For instance, this looks like 1/2 to the first. This looks like 1/2 squared, right? So instead of saying 5 to the 1/4, right? So remember, like 1/4, so 1/2 times 1/2 is equal to 1/4, right? So 5 to the 1/2 times 1/2, that would be equal to 5 to the 1/4. And if you want to do like exponents of exponents, well, that's not really nice, right? Because I don't want to do 5 to the 1/2 to the 1/2. So let's go with Jeff's suggestion here. Instead of doing that way, I agree. Let's think about, for instance, 5 to the 1/16th can be related to 5 to the 1/8 somehow. Whereby this is the same thing as, or let's look at this one. 5 to the 1/8 is the same thing as 5 to the 2/16, which is the same thing as 5 to the 1/16 times 2. And this case I like, because this is the same thing. So if you have exponents times exponents, it's the same thing as raising to an exponent. So this is the same thing as 5 to the 1/16 squared. Yeah. No, I think you were right the first time. Yeah. Because then look at this. So 5 to the 1/4, that's the same thing as 5 to the 4/16, which is equal to 5 to the 1/16 times 4, which is the same thing as 5 to the 1/16 to the 4th. And then 5 to the 1/2 is the same thing as 5 to the 8/16, which is the same thing as 5 to the 1/16 times 8, which is equal to 5 to the 1/16 all to the 8th. I like that. Okay. This, I think, is a good little strat for us. Because I can now say, let u equal 5 to the 1/16th. Okay? Then this would be equal to u squared. This would be equal to u to the 4th. This would equal to be u to the 8th. And I can replace those numbers here. And let's see what we get. So if we do that, we're going to get that x is equal to 4 divided by, and then, so square root of 5, that's just 5 to the 1/2. That's u to the 1/8, right? 5 to the 1/2 here is u to the 8th. So this is going to be u to the 8th plus 1, u to the 4th plus 1, u squared plus 1, and then just u plus 1. Fascinating. Very interesting here. One sec. Why is this should be loading, hopefully. Let's see. This is my test. Welcome, TikTok. See if that wants to work on our chat. No. Chat client's always weird with TikTok. Let's try it again. One sec. What's up, baby? How's it going? Nice. We're doing a little bit of math here. Okay, so let's see. The eventual end goal is to get x plus 1 to the 48th. How are we going to get there? So we're trying to get to x plus 1 to the... I'm doing good. Thanks, Ibby. I had a nice little nap. I went to the gym this morning. Now I'm going to the mental gym of Mathland. This is kind of a tough question. Ooh. X plus 1 to the 48. You did something that's similar? Okay. Do you maybe have a trick for it? Jeff is saying this multiplies out to a geometric series. Okay. Jeff, you want to enlighten me on like how that happens and why that happens? Well, you get 16 terms total. I agree. Basically, each combination of one term from each multiplicand. I see. So you're saying that u to the 8th is going to multiply by u to the 4th, multiply by u squared, multiply by u. So... And if you work those out, the terms, they're binary powers. I guess they are. So let's see what we get. So this is going to be 4 over... Hello, Joanne, my favorite. How's it going, Joanne? How's Chicago? 12, 14... But this is 8... This is u to the 15, dude. This is ugly. I don't like this. What? 8, 4 is 12, 14, 15? U to the 15th? Is that going to help me? Shy misses you. I miss Shy too. Right, so it's u to the 15th plus... So, Jeff, how are we going to get u to the 14th? I guess this will get me combinations of u to the 3, and then this will get me u to the 5. Wait, 3. 8 plus 4 plus 2 equals 0. Yes, okay, you're right. Okay. So when this, multiplies by this, and multiplies by this, yeah, we'll get you the 14th. Spicy Brownie says, can we do differential equations? We totally can. So Spicy Brownie, I'm glad you asked. If you want to submit a question to us, there's a website right there on the screen. Do you see where it says like actualdiscord.com/submit? So if you go to the website right here, we have a really easy way. You can just like type in your username. You can say like spicy whatever, spicy brownie. I don't know what a spicy brownie is, by the way, but are brownies supposed to be spicy? But if you take a screenshot of like a sample differential equation you want us to go through, I can do it. How do you share your screen like that? How do I share my screen? I use OBS. That's what I use. But if you want to submit a question... Oh, I think you know what a spicy brownie is, Mr. Burning Man. Yeah, I guess. Okay, I guess I do know what a spicy brownie is. Spicy brownie. Now here's my question, Jeff. The URL is broken? No way. I don't think it is. Did you type it in, right? If you just type in actualdiscord.com, it should literally just go to this website. Maybe check your spelling. I can't type the link in on TikTok because they get super mad at me. And they don't, like, let me post links. But that link should work. You don't even have to put the submit on it. You can just do www.actualdiscord.com. Maybe I should come up with, like, an even easier website, like www.q.com. I want that website would probably cost a lot of money. Ideas for the future. Okay. Let's see. AE.us. Nice. What's up, Bobby? We'll do your question next if you want. Yeah? What does u equal again? Good. So u, we said in this case, was 5 to the 1/16th. Such that Ibby, I could write this as u to the 8th, and then u to the 4th, u to the 2nd, and so forth, right? Wow, we got a raid from Obi. What's up, Obi? Nice to see you, Obi. Pleasure, pleasure. As always. Submitted. I got it. I do have your question. So watch, Spicy, I'll show you. This is your question, yeah? Let me pop it on the Discord. Sorry, you gotta see it on TikTok. There you go. So this is what you submitted to us, yeah? Yeah, cool. All right, we'll get to that in a bit. Let me just see if I can get this one real quickly. If I can't, I might punt on it just for a second. Becky has something with like, there's a lot of powers, And that's cool, River. You found out the basics of where fractals come from infinite tetration. Nice. All right. I think we want to notice like a pattern of some sorts, right? Dun, 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 dun. Basically, every combination of 8, 4, 2, 1 is either on or off. I agree. Okay. But I'm not seeing what I need to get to. I want to get to eventually x plus 1 to the 48. How are we going to get to that 48? You know, it'd be cool if I could just get what x plus 1 is. If we could just get this. Using the geometric sum formula, he says. Okay. Well, maybe. Let's see. Let's see. Because, yeah, I do agree with you, Jeff, that eventually you'll get, like, every power here. And then, okay. So this goes all the way down to eventually just 1. Okay. And so this is the summation from n equals 1 to 15, right? Of u to the n. U to the n minus 1, right? Is this what we have? That's what this is when we multiply all these terms out. And I don't think the terms double, right? Up to what question? Like Diffie Q. Maybe some complex analysis. Yes. But I think for geometric series we have to do this. Okay, because then what's the geometric series? Formula. Let me get the summation. Can we do discrete math? You can try, but I may not know it, honestly. Okay, let's see. I can try to learn discrete, but yeah, that is kind of like the upper knowledge of what I know. Ooh, woo, woo, I want to dance with somebody. Okay, cool. All right. So this I see here, right? Yes, this is the geometric series for S15. Right? Is that kind of what we see there? Yeah. So this is the same thing as equal to 4 over S15, I want to say. Dude, yeah, the index being off by 1. I hate the index being off. No. Okay, watch. This is for sure. This is it starting. This is the indices starting at 1. Right? I agree with this. Yeah, no, it's okay. This is what it is. You got college tomorrow. I got to enjoy. It's 1:30. Yeah, thanks, man, dude. Appreciate you coming by. All right, let's do this real quick. I think I got this. So what we noticed is that if you add up all of these terms eventually, you do need to end at 16. I agree. Great. Okay. Oh, that might help us out here. So one sec. Let's get there. Exactly. Thank you, Becky. Well, I start from 1 to 16 in order to get from u to the 0 to u to the 15. Okay, so this is S16. That's what we noticed from that. So that's going to be equal to the first term, which is just 1, right? And then that's going to be 1 minus u to the 16 over 1 minus u. Correct? That's what this whole bottom thing is. So eventually we're left with 4, 1 minus u, all over 1 minus u to the 16. Okay. Which, does that help me out? Because eventually I'm trying to get x plus 1 to the 48. Yeah, I don't think that we're trying to get this. So I think I want to get this in a form where I have like... Okay, now add your 1. What do you mean add my 1? Oh, I see. So he's saying this could also, because this is a difference of squares, I could also write this as 1 plus u to the 8th, 1 minus u to the 8th. Okay, cool. And then I could write this as 1 plus u to the 4th, 1 minus u to the 4th. And then I could write this as 1 minus u squared, 1 plus u squared. And then I could eventually write this as 1 plus u, 1 minus u. Oh my god, wow. Dude, this is and then, okay. So, this is equal to 4, 1 minus u, all over 1 plus u to the 8th, 1 minus u to the 8th. Or no, instead of the 1 minus u to the 8th, it's going to be 1 plus u to the 4th, 1 plus u squared, 1 plus u, 1 minus u, right? The u family tree. Yeah, that's a big fucking tree. Oh, okay. Oh, I think I see something here, guys. Okay. And then this will cancel with this. Okay. Okay. So now we're left with the Joshua tree. Okay, so now we're left with x is equal to 4 over... Oh, I think I see it, guys. I think I see it. U to the 4th. 1 plus u squared. 1 plus u? Right? How does that help me, though? I think it looks like a theorem says, yeah, maybe. And we did. Haven't you seen Math Lives in a while? Well, welcome, dude. We are the math channel. Okay. X is equal to 4. Okay. He says, actually, you want to add the 1 minus u to get your 1 there in the first and then factor. I agree. So here, I think we actually want to leave it like this. I think we want to leave... Let's not factor this out, right? We know that x is equal to this, yeah? But wait, we know what u is. Yeah? So can I just plug in... Oh, yeah. Oh, this is beautiful, actually. Okay, so wait. I don't think we need any of this yet. Let's get rid of this for now. We don't need this. Pretty sure we don't need this. This is cute that this all happens. I think I got it. Okay. This is equal to x, right? So I can just plug in what u is. U was 5 to the 1/16th. So remember, u is equal to 5 to the 1/16th. So 4 times 1 minus... Yeah, what's up, Addy? And then, watch this. This is really cool. This is over 1 minus... And then u is 5 to the 1/16th to the 16th. Right? Beautiful. Because look at this. This is now 5 to the 1/16th to the 16th. This cancels out. And then that's just 1 minus 5. Oh, super cool. Seeing these complicated math is kind of making me want to lock myself in my room and try to understand it. Well, come understand it with us. It's a fun little puzzle here. Okay. So, this is 1 minus 5 to the 1/16th all over 1 minus 5, which is negative 4. Okay, watch this. So, this is this. That cancels. So, I have negative 1 minus 5 to the 1/16th is equal to x. And putting a negative is the same thing as just flipping the signs here. 5 to the 1/16th. It's okay, Bobby. We're going to do yours next, and it'll be a little bit easier. This is equal to x. Oh, this is beautiful. Watch this shit. This is so cool. Now I move this over. X plus 1 is equal to 5 to the 1/16th. And our original equation wanted us to figure out what x plus 1 to the 48th was. Oh, it just pops out like that. That's so cool. I don't know. This is satisfying for me. It's just like a dope puzzle. It just like solves itself. Okay. So now this to the 48th is the same as this to the 48th. 1/16th to the 48th is the same thing as 48 times 1/16th. This is the exponent rules, right? So this is 5 to the 1/16 times 48. 48 over 16 is 3. You get 5 cubed, and the answer should be 125. What? Oh, that's sick. Oh my god. Hell yeah, dude. Lil Yachty's coming out for that one. That's super sick. Okay, cool. Sick. We did it. That was a really cool question. Thanks, Jeff, for kind of helping me with that one. I really did need some help. It looked incredibly difficult. How do I submit my question? You're good. You're good. You're listening from Discord. That's good. Yeah, this was the original thing. Complicated as fuck. We noticed a pattern. We did what's called use substitution. This is something you learn in calculus, but gets used in so many other things. And then once we did the use substitution, we then had to recognize that this was a geometric series. So then you start doing geometric series, which is something you learn in pre-calc, to write out what the sum of a geometric series was. And then it's just some cute algebra that eventually gets you to the right answer. So I think this is a really, really cool question that just shows you how math uses so many different levels of things in order to figure out really complex questions. Or in this case, it's just like a little puzzle. Good, Kevin. Yeah, did you find the website? I hope our bot is doing a good job at like telling you guys like where to submit things. Okay. Cool. River has one for Loppy Tall, Spicy Brownie. Let me do Bobby to Goat. Bobby, let's do your question. Okay, cool. So this is a summation question. Yes, you could write it as an infinite product notation with capital pi. Yeah, that's like the sigma, right? This always means like adding terms together. So for instance, if we wanted to write out a couple of these terms, let me just show you what it would be, right? So this would be the same thing. What does that E looking thing mean? What E looking thing? Oh, this. Yeah, let me explain this. Okay. So this is called sigma. I know you guys love the word sigma, right? Sigma. And this means it's kind of like computer programming. You're going to figure out what the value... Oh, sorry. One second. We gotta come back in. I got rid of the picture. Damn it. I got excited with the picture. There we go. One sec. Okay. There you go. All right. Yeah, so what sigma means is I'm going to evaluate what this is at n equals 1, and then I'm going to add it to the next term where I bump this n to n equals 2. And then I keep doing that up to 64. Good job, you guys, submitting, yeah, questions. Yeah, so the queue, you should see your name on the queue there. Although I think it only shows the first 3 right now. Right, so this is the same thing as 7 times, let's say, 1 plus 4, okay, all that together. And then we add it to doing the same thing, but this time, n is now going to go up by 1. So this is going to end up being 7 times 2. Okay? And then you get the same thing. This would be 7 times 3. And then so forth. All the way up to eventually 7 times 64. So what does the 11 mean? So for the first one, yeah, exactly, Bobby. Yes, so exactly, Bobby. The first one here would be 7 times 1 plus 4. This would just be equal to 11. Very good. This would be equal to 11. This would be equal to 14 plus 4, which would be 18. And then this would be equal to, good, Lucas. Yeah, exactly. 21 plus 4, this would be plus 25. Did I write 66? Oh, I did. You guys just want me to write 67. I know, right? Would that make things happier? We put like, can I put a 7 here?
That's dope.
No, you guys want 64. Okay, there we go. Okay, good. Thank you, Abdullah, for catching me on that. Yes. So let me, yeah, I know we can evaluate it, River, but let me show you where it comes from, okay? So we should notice something here, right? Do you see how as we're adding each one of these terms that we're always adding like 4 plus 4 plus 4 plus 4? And we're doing that like 64 times. I can kind of split this summation into 2 summations. And that's going to make my life a little bit easier. So let's see what happens. So I'm going to write this, instead of like one big scary thing, I'm going to write this as the sum from n equals 1 to 64 of 7n plus the sum from n equals 1 to 64 of just 4. So what I did is I kind of like distributed the summation. The summation is the sigma. It's this. Someone's asking for like Gaussian addition. Maybe. Yeah, I think you can do like the first term plus the last term, average them, and then multiply by the number of terms. That's the other way you can do it. Okay, but here. I want you to see like why this works, right? Because I'm going to get the same thing in my series. I'm going to get 7 plus 7 times 1 plus 7 times 2 plus 7 times 3. Yeah. So notice how this part will get you all of these terms, and then you're going to add them to all these, which would be plus 4 plus 4 plus 4. So what we did was... Exactly. Yeah, we're going to get to that. We're doing summations here. So, Bobby, what I did was, instead of doing this one big summation, I'm writing it as 2 simpler summations. And what we should know from addition, right, is I don't care the order in which things are added. So if I wanted to rewrite this as all the 7 multiplying things adding each other, plus all the 4 things multiplying to each other, like this, right? This would go all the way out to 7 to the 64. And then this would all the way go out to adding, just keep adding 4s. You can now write it as like 2 separate summations. Does that make sense, Bobby? So, no, n is not just the value we're trying to get. We're trying to do this summation, okay? So, there are some summation rules that make things easy. So, anytime you have something like this, which is just n equals 1 to 64 of just a plain number, this is also equal to just 64 times 4. And you can think about this, because this is going to keep adding 4s to each other, and it's going to do it 64 times, going from 1 to 64, right? This would be like n equals 1, this would be like n equals 2, this would be like n equals 3, and so you just keep adding 4s, but you're adding up to 64 of them. So adding 64 4s together is the same thing as just doing 64 times 4. Okay? Yes, okay. Now, let's look at this one. This is another cool thing we can do. This is another, like, summation rule. Okay? Where, when I have just a constant, like a number being multiplied here by n, I can just pull this number out and then do the summation. This is the same thing as the summation n equals 1 to 64 of 7n, but instead of the 7 being on the inside, I'm going to pull the 7 outside. And so now we just have this. The reason why you can do that, right, is because, again, I'm just doing 7 times n equals 1, 7 times n equals 2, plus 7 times n equals 3. And do you see how, like, a 7 is multiplying every single time we add a term? So I could add all the n's up and then just multiply it by 7, exactly, factor it out. This has a formula as well, which I'm going to try to remember it off the top of my head. I want to say it's n... I think it's n plus 64 divided by 2 times 64. Oh, yeah. And you said I'm the series master. Yo, shout out to Zach, dude. Yeah. Zach had an awesome stream today where he did one of the YouTube math warriors, giving me all these like hard math questions for me to do. Zach did one of yours during his stream. It was really fun. I really appreciated, Zach, you doing that. I need to like go through your solution and how you did it. Yeah, but it was fun. Lucas says, isn't it n times n minus 1 over 2 divided by 2? Oh, yeah. It's 64 times 65. No, so I was right. Okay. Yeah, so it's n plus 1. Yeah. I have no idea that Dr. Will listens to me. Yeah, so this is n times n plus 1 all over 2. Where n, technically this is n. This is bad that we wrote this as n. Sorry. Usually it's this. Usually this is x, and then this is n. Okay. All right. But, okay. Yes. What level math is this? This is kind of like pre-calculus. So, yes, constant. I think it is. Yes, this is going to be 65 over 2 times 64. Let me explain why that is in a second. We'll get that. So, we're going to get 65 times 64 all over 2. But remember, there's also a multiplied by 7 on the outside. And then we're going to add that to what we had here, which was 64 times 4. So the last step is just to add these two together. Exactly, yes. You love infinite series? Well, you would love Zach. Zach wrote the book on series, dude. He definitely wrote a book on series, and it was his master's thesis. Okay. He says, bro. I'm gonna keep saying you wrote the book on series, dude. That's gonna be your claim to fame, Zach. You can't deny, Zach, that you did write a book on series. You wrote a book. People are gonna start thinking I'm Euler. He's the reincarnation of Euler. Times what's it? Times 4. Okay, 7 times 65 times 64 over 2 plus 64 times 4. You end up getting 14,816. So he did figure it out. I did. I am smart today. Just today, though. So 14,816. What's A Drip? Yeah, what's up, dude? Okay, cool. So Lucas says, I thought there was maybe some shortcut about n times n minus 1 factorial over 2. Unless I'm talking about one of those shortcuts like the Taylor series. Yeah. Yeah. So this formula we did here, let me kind of like try to explain it, how it works. Oh, I do need to drink some water. Thank you. I need to hydrate. Oh, were you right, Lucas? Does that work? Here's why this formula works. If you have the sum from x equals 1 to n of just x, okay, and this is defined as being n times n plus 1 all over 2. Let's show like kind of how that works. So let's say you're going from 1 to 5. Gaussian addition works. Yay, nice. Let's say we're doing the summation from x equals 1 to 5 of just x. This would be the same thing as 1 plus 2 plus 3 plus 4 plus 5, right? And so let's just see what that is, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Okay, cool. And then let's see if that works with our other formula as well here. You don't like index being x? I like the index being x because it's to the n, right? Yeah, but watch this. So if we plug this in, right? So in this case, n is 5. So I'm going to say this is the same thing as 5 times 5 plus 1 all over 2. That's the same thing as 5 times 6 over 2. 5 times 6 is 30. 30 over 2 is 15. So you see how you get the same answer? Let me explain like kind of why this works, because it's pretty cool here. So when you take n plus 1 divided by 2, what you're doing is you're taking like the average of these two values. So this is 1, right? Really, I think what this is this is n plus like n naught, right? And then this is like n minus n naught, like if the series doesn't start at 1. But yeah. So here, this was 1. This was n. Yeah, exactly. I'll show you if it doesn't start at 1 what it is. I'll show you. It's cool. So n plus, how would I figure out the average between this number and this number, right? What's the average number of these two? The average would be adding them up and dividing by 2. Notice how that's 1 plus n all over 2. This is the average, right? So that's the average value of this series. And now I need to just multiply by how many numbers are in the series. And that's equal to n. Right? Notice I have 1, 2, 3, 4, 5. So that's why you get the average of 1 and 5 over 2. So the average value is 3. And then you multiply it by how many values there are, which is 1, 2, 3, 4, 5. And so that's how you get the answer is equal to 15. Yeah. That's how it works. You're correct. If it doesn't start at 1, you have to average. Let me think how this works. Okay. So if you have the sum, and yeah, let's say it's x equals 1. I'm trying to think how you do this. Yeah, if you submit it, I'll go through it. Let's say you have a series which is like, I don't know, like 15, 17, or let's say this, 15, 16, 17, 18, 19, right? You still do the first value and the last value. So that's going to be like, I think they call this A1 plus AN, and then we're going to divide that by 2, and then you're going to multiply by the number of terms between, sorry, let me get that right, between A1 and AN, okay? So if we wanted to do this, for instance, like this summation, let's say it was 15 plus 16 plus 17 plus 18 plus 19, I guess this would be the same thing as the summation for x is equal to 15 to 19 of x. This would be equal to 15 plus 19 all over 2. Very good, right? So that's 17. 34 over 2, 17. And then the number of terms you have, which is 1, 2, 3, 4, 5. And you multiply that by 5. And so that should give you a total of 85. And then we can check this, right, on the calculator. If we want to pull it up. Let's just do 15 plus 16 plus 17 plus 18 plus 19. You also get 85. See how you get the same thing? So yeah, that's how adding up series works for a linear series. Or this is called an arithmetic sequence, I think is what it's called. Or arithmetic series. Summation of an arithmetic series, yeah. When you're finding the c term from a trinomial, you can just do b squared over 2. What is that? Yeah, no, well, yeah. Yes, you can also do that. Yes. If the difference is always 1, you can do this minus this. That's how you figure out the number of terms. The number of terms here is 19 minus 15 plus 1. Because you always have to include the n bit. Yeah, that's also true. Okay, cool. All right, good question there, Bobby. I hope you learned a lot. You get a point, which I think puts you pretty close to gift card territory. What are you at? 9? Ooh, very close. Nice. Okay, good. How do you submit a question? So there is a website. If you want to see it, it's on the website. Let me see if I can pin. Can I pin comments here? Yeah. There we go. Let's see what the queue's at so far. Okay, cool. Yeah, I'll get to the Twitch coins as well. Good. Let me just give you like a little demonstration of what we got so far. So I got integrating factors. I got River with L'Hopital's rule. Spicy brownie. I got Becky with this. Becky, let's try yours. You want me to prove like why this is true? And then Spicy Brownie, you're next with your differential equation. So we're gonna go through this one first, and then we're gonna go do this one, and then we got another one. Lucas has a problem also. Ooh, Lucas, what is this? What is this question coming up here? Uh-oh. I see lots of stuff. Dear Schley, gonna hurt me. Yes, Lucas, I see it. All right, we'll try it out. Yeah, the invites aren't instant, but I'll give you invite credit in this, and like eventually. All right, let's do this one real quick. Oh man. So we're asking, what's the value of x that causes this to be true? You guys hurting me. Becky, always with the fun ones. Let's see if we know how to do this. Okay. I always got to get careful with my power to powers, right? Like, what's the order I can do? Can I do this? First of all, Becky, can I say this is the same thing as 8 to the negative 1 over x? Well, no, wait. Like, I always forget like how the parentheses work with things, if you know what I mean. Well, I can already write this. You do start from the top. Okay. Well, x to the minus 1 is 1 over x. Big log. Yeah, it's a big log. Okay, so here, let's... I think how this starts is we have this, and then this is to the negative 1 over x. Big log. Yeah, walk softly, carry a big log. Correct me if I'm wrong, right? And then 8 to the negative 1 over x. Well, I don't really know what that is. That's 1 over the 1 over the x root of 8. I think so. I always get... You guys love these exponents of exponents. Or no, sorry. It's the x root. It's... 1 over... 1 over the xth root of 8. Right? Are we good so far? Have I been doing things correctly? I think so. You think it's the negative x root? No. I don't think it's the negative x root. Also, like, how the hell do you do a negative x root? What's up, Anuvan? Yeah, no, the minus took it to the bottom. I agree. Right? This minus took it to the bottom. And then to the negative... So, right? 8 to the negative a is the same thing as 1 over, like, 8 to the a. And that's what we did with this. So instead of x... 8... So instead of 8 to the negative 1 over x, I wrote that as 1 over 8 to the 1 over x. Isn't the third root of just 125 cubed? No, this is weird. So this is 125 to the 1 over... Oh, you're right. No, you are right. Yeah. Because whenever you... Yeah, okay. So this is the same thing as 125 cubed. It is 125 cubed. I believe it is. You're okay with that. I think that's fine, because that's 1 over 3, which is equal to 125 cubed. Okay, cool. Man, we're getting a stress test in exponents today. I have the power. Okay, fuck. Alright. I think I can then evaluate this and then raise it to this power. Okay, I think that's okay. So, this I'm going to write as 3 to the 1/4. And we're going to raise 3 to the 1/4 to this. Which things I think means we're going to multiply them, right? So this is 3 to the 1/4 times 1 over the xth root of 8. That's what all this becomes. Becomes this. So now I have 5 to the 1/9 to the this. Which means it's just 1/9 times this. Double product rule, maybe. So I think it's... Well, I don't think we really have a... Okay, cool. Yeah, no, if you're studying for a basic calculus test, we can definitely help you with that. So, fuck. Okay, I'm going to get this. So this is times 3 to the 1/4, 1 over the xth root of 8. Oh, God. Okay, that's the same thing as 5 to the 1/3 squared times 3 to the blah, 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 blah. So I can write that as its own common exponent, right? So that's 5 to the 5 to the 3, and then it's going to be 1/4, 1 over the 8th root of x, or the xth root of 8, minus 2. So, random user, if you want me to help you out, best way for me to help you out is submit a screenshot of a sample like product rule question you need help with. So, yeah. Here's the way to submit the screenshots. Okay. All right, but then 3 to the this is times this, right? Okay, cool. So this is 5 times 5 to the 3/4 1 over the x root of 8 minus 6 all needs to equal 125 to the 3rd, which is the same thing as 5 to the 3rd to the 3rd. So that's 5 to the 9th, right? So this needs to equal 5 to the 9th, I think. You can't product rule because of power tower. What's the power tower? I can't raise this power to this and just multiply through? Yeah. I get confused with, like, where the fuck all the towers go here on this stuff. Yeah, just write it in LaTeX if you want. I don't know why this is here. I'm tempted to say this. 3/4 1 over the 8th root. The x root of 8 minus 6 equals 9. Let me just see if it works. Plus 6. 15. Times 4/3 is equal to 20. So 1 over the x root of 8 is equal to 20. But I don't know how that's going to work. 8 to the negative 1 over x is equal to 20. Random user said, did that work? Oh, did your screenshot go through? It did, random. I saw it. I see him right here. Okay. One sec. TikTok's getting mad at me. Okay, so that's going to be negative 1 over x log of 8 is equal to log of 20. So I said x equals negative 1. Yeah. Right? Bring out the 1 of x. I agree. And so x is equal to negative log of 8 over the log of 20. Cool. All right. I don't know if this is right. I'm going to try. I think it's right. But this was the massive thing. Okay. If someone wants to do a write-up of, like, the exact, like, power tower rules here, I'm more than happy to go through it. But let's see. The queue's already up to 9 questions, so let me run through a little bit. All right, cool. Good question, Becky. I appreciate it. It's cool. All right, next question coming up. This one comes from Spicy Brownie. This is a differential equations question. Okay. So let me see. Is this homogeneous at all? And is it separable? I do like this. I like this over here. That's pretty cool. Because I also see it over here. Right? XD. So in differential equations, you always have to identify what kind of family this question belongs to, like what type it is. So I usually don't like things in front of the dy dx, so I'm going to divide that through, also because I see it over here as well. So this is going to be dy dx plus 2xy over x squared plus 1 is equal to 1 over x squared plus 1 squared, right? And when this happens, is this integrating factors? Let me see. Paul's math notes is great. I love Paul's math notes. Let's go to Paul's math notes. He's a G. Yeah, if you guys ever want like a great... Okay, this is actually what I fucking want. Nice. Yes. Yeah. Okay. So anytime you have, like, in this case it's dy dt, but if it's dy dx, here, let's see if this is what we have. I think it is. Yeah. I think this is the same. You always want to try to match the form. So let's look. Yeah. I do have dy, dx is dt in this case, dt. I have a function just of x, that's this, times y, great. And then I'm left with just a function of x, which I am left with here, cool. Okay, that's awesome. So yeah, this is integrating factors. Yeah. It's not homogeneous though, unfortunately, right? If it's homogeneous, it'd be super easy. Okay, so what does Paul say to do this? I forget what the integrating factor is. Blah, 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 blah. Yeah, you multiply it by something. What do you multiply it by? I know what there's a cool way to do it here. Okay. Wow, look at this. E to the integrals of integrals. E to the integral of k, e to the integral. Okay, I think the integrating factor is e to the, this looks like e to the pt dt. Yeah, differential equations are cool. So in this case, this part right here is what we call p of t. And our integrating factor, and then I think you just multiply everything by it, right? So the integrating factor is equal to e to the integral of 2x over x squared plus 1 dx, right? And this is a beautiful integral. I love this integral. This is one of the best integrals ever, right? Because this is very easy. Notice how I see something and I also see the derivative of it somewhere else. In this case, this is where u substitution comes in handy. If u is equal to x squared plus 1, then du is equal to 2x dx. That shows up right here. So I literally just have the integral of e to the du over u, which this is also fucking nice, right? Because the integral of du over u is just equal to ln. So I have e to the ln of u. Technically plus c as well. But maybe I'll just ignore the c for now. Like, we'll throw the constant in later if I need to. U sub, right? Yeah, cool. And then e to the ln of u is just equal to u. That's awesome. And then remember that u is equal to x squared plus 1. Cool. Nice. So I think, what's the next thing I do here? I think I multiply everything by it. Do I not? Let me see, Paul. What do I do, Paul? Once I get it, what do I do it? Yeah, so there's our integrating factor. Find the integrate, multiply everything by mu of t and verify that the left side becomes a product rule, and then write it out. Integrate both sides. Sorry, to make sure that you're dealing. This is cool. I do like, dude, Paul's great. If you want the explanation for like why it works, please watch this website. Or, like, yeah, read this. I'm just going to show procedurally how this works for now, just because the queue of questions is quite long. But, yeah, Paul is a real one, dude. But there you go. That's the... Could you have done the integral of arctan? I think we're going to eventually. Oh, you're saying... Oh, would that have been the integral of arctan? Well, arctan would have been 1 over x squared plus 1. I don't think you would have had a 2x up here, no? Also me. Obi says, also me. Obi, is your name Paul as well? I didn't know that. Okay. So, step 1, put it in the correct form. We did that. Nice. That's this in the correct form. We then found the integrating factor. Great. And now we multiply everything by mu of t. So let's do it. So that's going to be... dy dx times x squared plus 1 plus, look at this, x squared plus 1. If I multiply this, I just get 2x times y, right? And then if I multiply this by x squared plus 1, I just get 1 over x squared plus 1. Got you, River. I appreciate all the columns there, yeah. Oh, nice. Yeah, if you want to know how DiffyQ works, yeah, talk to Obi. Yeah, shout out to Obi. Obi's great. Yeah, if you're watching us on Twitch, Obi's another great streamer. And yeah, he taught a lot of differential equations. So he can probably explain the why. I'm going to show... This is actually really cool, though. Because this is a product rule. Because look what happens, right? Let's say I had y times x squared plus 1. And I did d whatever of this. Let's say like d dx of this whole thing, right? We know that d dx of a times b is the same thing as a prime b plus b prime a, right? This is the product rule. So in this case, this is the same thing as dy dx, derivative of the first times the second, x squared plus 1, plus the derivative of the second, so d dx of x squared plus 1 times the first. And look at this. The derivative of x squared plus 1 is literally just 2x. So you get dy dx, x squared plus 1, plus 2xy. And so this is really cool. This, which is literally this, is the same thing as this. All right, so I'm just going to get rid of this, just so give me some space here. Okay, super dope. 1 over x squared plus 1. You wouldn't even need an integrating factor. You could integrate everything outright. No. Let me see from here. Correct. Well, I mean, that's what you're doing. You're multiplying everything by x squared plus 1. This is a very lucky case. This is a very simple case that this works out. That yes. Yeah, you actually could have just identified from here right off the bat that this is literally d dx of y times x squared plus 1. Okay. You're totally right, Jokes, that I didn't even need to do this, but very rarely will it be this nice. Yeah. But I want to show like kind of why this works. Because now if I have d dx of something, right, is equal to this, I can just move the dx over here. Okay? And then we take the integral. The integral of d whatever is just whatever. Okay? So this comes down just as it is, technically plus c. And then now we have the integral of 1 over x squared plus 1, which, yes, is arctangent. Good? So now I have arctangent of x is equal to y x squared plus 1 plus c. So I think the answer is just y is equal to arctan x all over x squared plus 1. And then it's technically minus c over x squared plus 1. But this can get absorbed into, like, another c. And, like, c could be negative or positive, so I don't really give a shit what it is. So I can just, like, put this inside of it, I think. I can just say this is the same thing as, like, plus c up here. And then I think you're done there. Nice. That was a fun one. What's up, Maria? How did physics go? Ooh. Can you help me, please? Yes, Maria. I got a little bit of a queue of questions. Let me fix the queue so far that we've gone through. So we did Becky's. Sorry, I gotta add the. We did Becky's. I did spicy brownie. Oh, random user submitted 4 different questions. Okay, I'll do one of them. All right, let's get Rivers. Okay. But yeah, I see yours, Maria. If you want to help me, one sec. I'm gonna show an example of like how your question would get added. Let me put this in the downloads. Yeah, so, oh, you meant just the very last one. Okay, I got you, woohoo. I got you, random user. So, just for those that are watching, if you want to add your question to the queue, just go to submit.actualdiscord.com or whatever it is. And so here, I'm going to put your name, watch. I'm going to say Maria, and then I can drag and drop in your image, and I'm going to hit upload. And then you should see something here. Eventually, they'll say, cool, your screenshot was received. This is how you know that we received it. So now yours is added to the queue, because if we go here to the queue of questions, you're right down here, Maria. Also, Yadavir, yeah, you asked questions on yesterday's stream, Yadavir, so I will help you out as well. Guys, I'm a veteran here. Yeah, Maria has been here a while. Okay, let's see. Yeah. So, yeah, first of all, this is... someone's going to get mad at me if I say La Hospital. I was joking with people. It's technically L'Hôpital's rule, is what it is. I say La Hospital to, like, fuck with people as, like, trolling. It's kind of funny. All the math people get really sad at me when I say La Hospital. Okay, so, how L'Hôpital's rule works here, right, is we say if I have a function that is equal to, let's say, like, some g of x over some h of x, and that is in what we call, like, indeterminate form, so that's either, like, 0 over 0 or infinity over infinity, then, and sorry, this is the limit as x approaches a, whatever, or it's, yeah, the limit as x approaches a of f of x is equal to something on the top, something on the bottom, and if that's in this form, then the limit as x approaches a of f of x is also equal to, and Twitch, I'm fine with it, okay. And then, correct me if I'm wrong, Obi, does it have to approach infinity, or is it okay for it just approaching a? I didn't see your write-up on tetration. Sorry, I had to go teach logic. I saw you do the one question. Who asked the tetration? Oh, River. Yes, River. One sec. River. So Zach, I think, did do your tetration question. So if we go to Zach's stream here, was it? Is it? Or here it was. Yeah, good. Okay, awesome. Yeah, this is where I think I stopped watching. Zach was around here. Okay, and so this, where did we do the tetration? Let me see. Oh, you wrote it up in your Discord. Okay, cool. But yeah, this was also good. Ren, he did your question there too. Yeah, okay. All right, I'll send the link to your Discord, Zach, to make sure people see it. Okay, let me just explain, like, what L'Hôpital's rule is, and then we can kind of, like, delve into, like, why it is. This is also equal to the limit as x approaches a of df dx over the limit as x approaches a of df of y. Or, sorry, dg, sorry, this is g over h. Sorry, this is dg dx, and then this is going to be dh dx of x. And then you can, like, keep doing this until eventually you get, like, the right form. Negative infinity over infinity, I think, is okay, too. Yeah. I think it just has to be, like, 0 over 0. It has to be, like, some, like, indeterminate form. If you're in any of my chats and you're a better mathematician than me, please, like, correct me if this is wrong. What's our streaming schedule? So, Lane, if you go to the website and you click on streaming schedule here, that has our whole schedule there. And then if you want to know how to submit a question, there's the way to do it there. Right. Yeah, any sort of indeterminate form, which I think negative infinity over infinity works as well. Well, no, it's Yes, but infinity over infinity is not the same thing, right? Okay, let me put this here. Let me dump this into LaTeX for you real quick. No, not that. Fuck. Let's see if that works. Cool. Yeah. So, for instance, let's take an easy example, because this comes up a lot if you're ever studying horizontal asymptotes, guys. Let's say, for instance, you have f of x is equal to, like, I don't know, 5x to the third plus 1 over, well, let me make it easy. Let's say 6x to the third plus 1 over 2x to the third plus x, okay? And you want to figure out the horizontal asymptotes. So that's figuring out what is the end behavior of this function. And the end behavior means that on a graph, what is happening as I go very far to the left or very far to the right, which is as x gets closer and closer to infinity. Okay? The way to write this is as a limit. I could say, okay, well, what's the limit as x approaches infinity of 6x cubed plus 1 over 2x cubed plus x, right? If I were to just plug infinity into here, notice what you would get. You would get 6 times infinity cubed over 2 times infinity cubed plus infinity. Yeah, you can just try to, like, plug it in and just see what happens. Now, this is kind of weird, right? Because infinity is not a real number. It's more of a concept. It's, like, the biggest number ever, but we don't know, like, how big it is. So, so infinity cubed is still infinity. And then 6 times infinity is still infinity. And then infinity plus 1 is still, like, infinity. Same thing here. This is also infinity, right? So I don't really know what this is. You could make the argument, right, that I think maybe this is approaching infinity faster, right? Because there's 6 of these infinity cubes, versus like 2 of these infinity cubes. But the better way to do this is to use L'Hopital's rule. And then I'll show you, like, the really simple way you can do it for horizontal asymptotes. So because you have a situation where you have infinity over infinity. Nice, yeah. Thanks for the follow, by the way, Grubhog. What you do here is you now take the derivative of the top and the bottom. Because what we're doing is we're saying, okay, I don't know what that function is approaching, but let me see the rate of change that function is approaching. Like, when you take the derivative of this with respect to x, you're checking out what is the rate at which this thing is approaching infinity. So now you're comparing effectively the rates that, like, how fast it's getting to infinity. So when you do this, you end up getting 18x squared, and then this becomes 6x squared, right? Plus 1. Okay. So still can't really tell what's happening. It's still technically equal to infinity over infinity. So I gotta do another derivative. But the cool thing is, like, you can keep doing this as long as you need to, provided you still keep getting infinities over infinities. I will show the x cubed. Yes, that's the major trick. So now you have the derivative of 18x squared over the derivative of 6x squared plus 1. This is going to get you 36x over 12x. And this derivative goes away. This is simplified, right? Because I have an x on the top, I have an x on the bottom. And now I just get 3. And so I can say, okay, the top is approaching this infinity 3 times faster than the bottom. So eventually, the limit will just go to y equals 3. Yeah, derivatives do preserve ratios. I believe they do. The easier way to do this, and this is the way I teach everyone in, if you're in, like, early high school and you haven't done calculus yet, you just look at what the highest power of x is, which in this case is x cubed, because this is just x to the first. And you divide both sides by the highest power. So I'm going to divide this by x cubed, and I'm going to divide this by x cubed, and watch what happens. So now you end up getting 6x cubed over x cubed over 1 over x cubed Yeah, for sure. Yeah. Good luck with math and physics, random user. I know the time zones are probably late for you. And so when I do this, watch. X cubed over x cubed cancels. So we just get 6. Plus 1 over x cubed. All over. These cancel. 2. And then x over x cubed is 1 over x squared. Now, if I'm taking the limit as x approaches infinity of this, I'm just plugging in infinity into here. Okay? Cool thing about that is that 1 divided by infinity is defined. That is 0. 1 divided by the biggest number in the world is nothing. So this is going to go away as 0. This is going to go away as 0. And you're left with 6 over 2. And you get the same answer. 3. And so a lot of times you'll tell your teacher there's a horizontal asymptote at y equals 3. So that's the other way to do it. But L'Hopital's rule is kind of like a more rigorous iterative way of doing it. Yeah, you forgot about that method. It's a really cool method. Thanks, Kevin. Yeah, this is the easiest way to do it. But limits are more professional. So in this case, you end up taking yeah, I forget what you do here, but this ends up just equaling E. That's how this works. But yeah, okay. Let me get through some other questions, but I hope this kind of like makes a little bit, this basic example at least makes sense for how like L'Hopital's rule works. Good question. Hang around. If I have more time, I'll go more in depth into like exactly how it works for ln. Yeah, it's okay. I don't fully understand how to do it, honestly, as well. Yeah, but it does work, and it's cool. It's sick.
That's dope.
All right, nice. So, we'll clear the queue from... Sorry, where's that question? From River. So, this is Kev's question. Find the integrating fact... Ooh, Jesus. Okay, here we go. Find the integrating factor mu x to the m x to the n, which makes the given differential equation exact, and then solve the equation. Okay. Let's see what's going on here. Well, is this in the form I want it to be? I think for integrating factors, I need to divide this out, no? So this is going to be y prime plus 2y to the 5th over x to the 5th, y to the 3rd, minus 4xy to the 4th. And then I want one of these to just be... What does it mean for an equation to be exact? Oh, I have to remember diffie-q. I think for an equation to be exact, it's something where like dm dx minus dn dy is equal to 0. Where I think you have like m dy plus n dx. Oh, okay. Good, Obi. Obi's our resident diffie-q master. Okay, for something to be exact, it means you need ax prime plus by prime to be equal to 0. Which, okay. I think usually in math land, we call this like m, and we usually call this like n. Right. And when that happens, I need dm dy to equal dn dx. Was I right about that? I think so, right? So if this is exact, then dm dy must be equal to dn dx. And then there's a really nice way to solve this. And I think it's another like product rule. Oh no. You're playing your spaceship game again, Obi? That's cool. Okay. Cool. So, in this case, M needs to have something... Wait, where is X prime on this? Sorry, what? Oh, I think I understand. Okay, 1 sec. I think I see how to do this. Okay. We're going to rewrite this as dy dx. Let's do that. Yeah. So x to the 5th, y to the 3rd, minus 4xy to the 4th, and then this is dy dx. That's because that's what y prime is. And then this is all equal to negative... actually, no. We're going to leave it over. We're going to say equal to 0. And then this is plus 2y to the 5th plus 3x to the 4th, y to the 4th. But what I'm going to do is I'm going to multiply through by dx. Math people get mad at me for this. I'm going to do it. I'm just going to multiply both sides by dx. Multiply by dx. Multiply by dx. Dx gets munched. So I don't really care about that. And then, so now this dx goes on to here. Right? Because dx will cancel with this, but then this will gain a dx term. Okay, so now we have this dx. Yeah? Drury says the answer should be 2x minus 7y is equal to kx to the 8th, y to the 7th. We'll see. Here, I'm gonna... We're gonna keep your prediction up here, Drury. Let's see if you're right. Okay. So when this happens, then this is M, and then this is N, right? I think. Yeah. And then, but I want some integrating factor. So integrating factor usually means I multiply the entire equation by mu. So I want this multiplied by mu and this multiplied by mu. I don't care about this. The 0 is going to eat the mu. Such that, so I want d mu n dx to equal d mu m dy. Because when this is true, this is really easy to solve, right? Oh, you gotta go sleep in 10 minutes? Oh. Alright, sorry, Maria. Maria, we're gonna stream tomorrow if you want. It's gonna be earlier. So, if you want, come by the Discord tomorrow. It's gonna be at 4 o'clock Pacific. Or your test is tomorrow. Oh, okay. Can I do yours real quick then if you're going to leave in 10 minutes? Sorry, can we pause on this question one sec? Just so I can help Maria before her test. I can do it. It's okay. Let me see. Which one do you need? I do take a little bit of priority to students have tests. Do you want to come to the stage and talk too, Maria? I can invite you if you want. And then we'll get back to the calculus. I'm very, very close to that. Yeah. What's up, Maria?
You could talk here.
Yeah, you can talk here. You can say, well, I mean, within reason. Yeah, don't get me banned off Twitch, please.
All right. Yeah.
Okay, what's up? What do you need help with on this for physics?
I don't even know where to start because, like, I was doing the test that I missed when she was going over it. So.
Okay,
I don't
cool.
even know where to start.
Okay, let's start real quick. Okay, so I like drawing pictures, right? So. We have a balcony that's 3.3 meters high, right? And she's throwing a ball straight upwards, yeah? And then this is going up with a velocity v0 is equal... And you're right, Jeff. Yeah, I'm not streaming tomorrow. I forgot. Yeah, I have the thing with Zach. How long is it in the air? Great. Cool. So, let's think about this. If she's throwing it straight upwards, the ball's initially... going which way? Is it vertically, horizontally, or like both vertically and horizontally?
Vertical.
Good. Right, there's no horizontal movement. So it's just vertical, okay? So we only have to worry about stuff in the y direction, okay?
Okay.
And so we don't care about anything horizontal. This can all go away. So, yeah, let's talk about the trip up and the trip down. Sure, okay. Because what's going to happen here, Maria... This is going to come up here to some, like, maximum height. And then it's going to fall back down. But ignore the left-right movement. It's not actually going left-right. It's just going up and down. Does that make sense?
Yeah.
Okay, cool.
Sorry, I'm like sick.
It's okay. I was kind of sick earlier too. Yeah, you're fine. There's something going around. It's bad. Okay, this is down where h is equal to 0. Okay. So, on the way up, your initial velocity is 5. Your initial height, which we can call y naught, is equal to 3.3, right? And then in order to figure out getting to the top, this is going to be equal to y max. We don't know what that is yet. But we do know something. What happens when the thing gets to the top? What's the velocity at the top?
Isn't it 0?
Good. Yes. The thing is going up, and then as it goes up, it starts slowing down. And then eventually here, it's going to have Vy is equal to 0. All right? So let's compare what happens between these two situations by using one of the kinematics equations. All right? Because we want to figure out how high it goes. A good equation that you may have known is the timeless equation. So this is like v squared is equal to v naught squared plus 2a delta x. Or in this case, delta y. Have you seen this equation before? It's okay if you haven't. You haven't? Okay.
No.
Let me pull up the kinematics equations.
What?
I'm gonna pull up pictures. You tell me which one you've seen. Have you seen any of these?
I've seen the third one. I've seen the third one.
Oh, so you've seen... Okay. Let me see. Let me copy this in. Okay. So you've seen... Oh, man, it just went away. Come back. So you've seen this one?
Yeah.
Good. Okay. That's fine. So what that says is that the final velocity of something squared is equal to the initial velocity squared plus 2 times the acceleration times the change in the position. Okay?
Yeah.
So this is an equation we can use to figure out how far up it goes because it has all the things that we know. I know what the final velocity is at the top. What's that? When it reaches the top.
The 5.
So, no, the 5 is the initial velocity as it's going up. But as it starts reaching the top, it goes to 0, right? Good. So, you have 0 squared is equal to your initial velocity. That's the 5 squared. Plus 2 times a. Do you know what a is for something that's in the air? This is also called, like, free fall. Not 0.
Or 9.8.
Negative 9.8.
Oh, yeah.
Good. In the y direction, okay? In the x direction, you're right, there is no acceleration. But because things are going up and down, gravity is the acceleration. That's negative 9.8. And then delta x, so this is y final minus y initial, right? And my y initial was 3.3 meters. Because that's where we started. Okay?
Yeah.
So now you can solve for how high this thing goes, right? So let's move things over. So 25 over, this is negative 25. And then we're going to eventually divide by negative 19.6. That's just like multiplying these two things together. And this is going to be YF minus 3.3. This is basically 25 over 20, which is 1.25 is equal to YF minus 3.3. So then YF ends up equaling 4.55 meters, okay? So that's the maximum height it reaches the top. Is going to be 4.55 meters up.
So that's the answer?
That's the answer for... Okay, that's the answer for this stuff. I was doing all this first, right? So, yeah. So this was... this was 5. This ends up being 0. The distance it travels is technically 1.25. The acceleration is negative 9.8. And now we need to figure out the time. So how do you think we figure out how much time it takes for the ball to get from here up to here? We've got to use one of these other equations, yeah?
Another one that she made us use is like D equals VO T plus 1/2
This one right here.
A and then T to the second. Wait, I'm gonna put it in the chat.
Oh, it's this one right here, Maria. I see it. Right? Is this one?
Yeah.
Okay.
It's just written differently, I think.
Okay. Yeah. So delta x is basically d, and so we know the distance it traveled from what we did here. We did that. That was 4.55. Okay.
Mm-hmm.
So we're gonna write that as 4.55. So that's this equation. Is equal to your initial velocity, which is 5 times t. It's not 4.55, it's 1.25. Because this is the change in the position, and the thing went from 3.3 up to 4.55. So the change is 1.25. And then this is plus 1/2 at squared, so that's plus 1/2. Acceleration is negative 9.8. And then it's t squared. Okay?
Yeah.
Now, this kind of sucks because this is a quadratic equation you have to solve. Yeah. Do you want to know an even easier way to do this without doing the quadratic equation?
No. She said that was the only way to do it.
No, you can do this one. Because watch this, Maria. You know what the final velocity is, right? Final velocity is 0. The initial velocity was 5, right? And then it's plus a, negative 9.8, and then just times t.
There's no way.
Yeah. Yeah, way. This is the way easier to do it. Way to do it. So now, you just get negative 5 over negative 9.8 is equal to t, which is basically equal to 0.5 seconds. And that's it.
Okay, hell yeah.
Yeah.
Thank you.
You could have done this way with the quadratic equation, but it just sucks. And I don't know, you feel sick, so I know you don't want to do all that stuff. Okay. But wait, that's the time for it to get up to the top. Thanks for the rose Kotick. Then you have to do the time for it to get back down to the ground. This one, you do kind of have to use the quadratic equation, unfortunately. Because I don't know what the velocity is when it hits the ground at the bottom. Well, not easily. Okay. So, as it's coming down, we do need to use this equation. And so, the distance we know it's going to travel is from the very top to the bottom. So, that's going to be negative 4.55. It has to come down 4.55 meters. The initial velocity at the top is 0, right? Remember this had 0 initial velocity at the top?
Yeah.
Yeah, this is the weird thing. So the initial velocity here was 3.3, and then the final velocity at the top becomes 0. But now in the next situation, the final velocity from the first situation is now the initial velocity in the second situation. I know, it's a little complicated. Yeah, she's like, okay. So this is equal to 0, because there's no velocity when we're dropping from the top. So I don't actually really care what time is here. This is great. And then, here we go. Plus 1/2 negative 9.8 times t squared, right?
Yeah.
This is really cool. So this will multiply together, so you get negative 4.55 is equal to negative 4.9 t squared. Divide by negative 4.9. Divide by negative 4.9. I should get an actual number for this. I shouldn't approximate this as 1. That would be bad. Alright, so we'll do 4.55 divided by 4.9. And then we're going to square root that. Okay? And that's going to get us 0.96. So t is equal to 0.96 seconds. Okay?
Okay.
That's the amount of time for it to fall down. Okay, so for it to go up was 0.5 seconds. Okay? For it to come down was 0.96 seconds. So the question asks, what's the total time it spends in the air? What would that be equal to?
Don't you just add them together?
Yes. So it's going to be equal to 1.46. So t total is equal to 1.46 seconds. And then you're done. Is to make a little bit more
Okay,
sense?
hell yeah.
Hell yeah.
Yeah.
Nice. Awesome. We love that. Okay.
Yeah.
I'm gonna save the screenshot. I'm gonna put it in the chat so that you can like study it later and stuff. Yeah.
Yeah.
Okay. Maria. Okay. Great. There you go. Cool. Well, I hope you feel better. Good luck on your test tomorrow and everything. And yeah, come by the streams. We're streaming on Sundays now too. So if you have other shit that's coming up and you want to get some help on Sunday, come on by. Cool.
Oh, trust me, I will be back. Thank you.
Nice. You're welcome. All right, nice. All right. Sick. What's up, Justin? I got to go back to this calculus question. Thank you. Whose question was I working on? Kev? Thanks for understanding. Maria, I know, has a test tomorrow. I just wanted to help her out real quick before she goes to bed. And it sounds like she was kind of sick, too. I've been sick as well. Mike Brongus, Mew Mew. What's up, dude? Okay. The future has measurements to be calculated. Sebastian said, are you able to find the second derivative and vertical horizontal? Blah, 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 blah. Yes, I can do that. Cool. Also, are you or anybody in the Discord able to tutor for an AMC competition? I don't know what that is. Is that American Mathematical whatever something? Maybe. Okay. Let's see what this one was. Yes, yeah, I did do physics at university. I got my PhD in physics. Justin, why does your mic never work, dude? Is there something wrong with Discord? No, you're good. Physics. Yeah, it's okay. English, I know it's difficult. You're okay. All right, let's see. I needed dun dx to equal dum dy in order for this to be exact. So I need mu times all this. Oh, nice. You need like a little refresher? Yeah, for sure. You're more than welcome to ask questions during the stream here, but yeah, I also admit, yeah, if you want like a lot of help, as you can see, the queue's already 9 questions long, so like there's always a lot of people asking. You could maybe find another student in my server. Join my Discord, by the way. If you join my Discord, I can try to pair you up with other students that are motivated to do like math competitions. I mean, River might like them, right? You like math stuff. Yeah. Yeah, he hasn't done anything yet. Exactly. But River would love to like try it out. I just always take partials to be safe. Jokes. I also don't really understand the difference between partials and full derivatives. I just always write partial just to be safe. Okay. So wait. Oh, but I need this dx to equal this dy, right? Ooh. Oh, man. This is kind of fun, actually. Fuck. And wait, u has to be a function of x and y, right? Oh, okay, wait. But we know, guys, right? We know that, you're doing God's work. God bless. Many of us improve. Yeah, awesome. That's cool, dude. Yeah, no, I do think streaming is the future for education because none of y'all like textbooks. Or I think like just like digital media in general, like interactive stuff, videos. I think nothing will ever replace doing questions. You should always do practice questions, but I think the way you guys intake information, it's a wild world these days. Yeah. I think it's cool. But yeah, that's what we try to do here. Okay, but mu's of the form x to the m, y to the n. Okay. So this is x to the m, y to the n. And then this is x to the m, y to the n. Okay. Yeah, exactly. And I think, honestly, like, AI will kind of, like, adapt to, like, the learning as well. At least for the basic stuff. Okay, if I multiply this inside, do I get something cool? So what was that going to be? X to the 5 plus m, y to the n plus 3, minus 4 to the x to the m plus 1, y to the n plus 4. Whoa, partials. Yeah, holy partials. And sorry, this is still ddx. Is equal to ddy of 2x to the m, y to the n plus 5, plus 3x to the 4 plus m, y to the 4 plus n. I think also the other cool thing about, like, streaming is if you're just, like, watching, I mean, it's better than, like, doom scrolling on other stuff. Even if you don't understand this, you get exposed to it, and it starts to kind of, like, seep in. You see enough of this, eventually it'll start making sense. Okay, so then partial x of this whole thing. Okay, so this ends up pulling this down. So I get 5 plus m times... that's me x to the... So you pull the derivative down, you pull the exponent down, you drop it y by 1. So that's going to be 4 plus m y to the n plus 3 minus, and then this is going to be... What is that going to be? 4 times m plus 1. So let's say 4 times... Or let's say 4m plus 4. And then that's going to be x to the m, y to the n plus 4. Okay, that's what this side is. And then I hope there's a fucking common factor here somewhere. This is going to be n plus 5. Because now we're taking derivatives with respect to y. And then we're going to drop some things down. So that's going to be 2x to the m, y to the n plus 4. I'm kind of seeing this. That's kind of cool. Plus 12m plus 3... 12 plus 3m. So what's happening is I'm pulling down this. Sorry, 12 plus 3n. Right? And then that's going to be... Yeah, patterns, exactly. No, I agree, you all, for sure. Yeah, a lot of students ask me, like, why the fuck are we learning this? Like, when am I going to use this in real life? I'm like, probably not. You're probably never going to use this in real life. But the fact that you're having to make, like, neural connections in order to solve this, those neural connections help you solve other things. Like, how do I do my laundry? Well, I mean, other more complex things. Yeah, it's for fun. It's problem solving. Yeah, I think that's a cool... I try to make it fun. I try to make, like, this is, like, kind of fun. And for students who don't think it's fun, I try to incentivize them by, like, putting rewards on it. That's why, like, we buy gift cards. We buy tons of stuff for people. I actually just found out that Ethan, who's in our Discord, he won the summer camp, but he got his Nintendo Switch too yesterday. He's like, look, it's real. So yeah, I do buy things. Yeah, Ethan won a Nintendo Switch too for our summer camp. And Ethan's been, like, strongly motivated to do things in math. I don't think maybe he would have been normally if we hadn't, like, brought in the incentives first. So it works out. When am I gonna get to use martial arts? Come to Los Angeles, dude.
Surprise, motherfucker.
You'll use some martial arts, dude. Okay. Let's get rid of Discord. Okay. So now this is what I have. Do I have anything that's, like, kind of cool here? I think too. Look at this shit, guys. Watch. Look. This is the same as this. Right? Okay. So this is where you can, like, group by terms. I know that this must equal this. Right? Because they have the same coefficient on them. So I know that, like, 5 plus m must equal 12 plus 3n. And then for these ones, I know that 4m plus 4 must equal... You gotta bring the 2 out. 2n plus 10. Sick. This is just a systems of equations. What's up, Meeson? Yeah, this is 50Q. We're doing a little bit of Diffie Q today. Okay, so let's like try to like group some shit. Okay. So I'm going to say m minus 3n is equal to 7 from this. Move that over, right? Move that over. And then from this, I'm going to say 4m minus 2n is equal to 6. So let's do the elimination method. I'm going to call this 4. I'm going to call this 12. I'm going to call this 28. I'm going to subtract. So I get negative 14n is equal to 22. It's kind of ugly. I was hoping it would be nice. Is it not a nice number? Fuck. I fucked up somewhere. Oh, wait, no. Negative 12 minus 2 is 10. Sorry. 10n. Right? 10n is equal to 22. Yeah, why did I make a systems of equations? Okay. Isn't substitution better for this? I just like see like nice things. And I want nice things, you know, it looks nice. Yeah, that should be fine. Why is that not working out? It should be a coefficient. It should be a nice coefficient. What am I fucking up on? Yeah, so how this worked is we wrote out our original differential equation like this, and then we recognized that this is like n and this is m. Vua says, not only fun, but life-saving. I mean, career-wise in Africa and South Africa, only 20% of students are doing better in math, yet our economy demands more people. Yeah, exactly. You want to get a job, make some cash? Go learn math. Go learn some math. Okay, I fucked up somewhere here, though. Sorry, I gotta figure out where we fucked up. Okay. X to the m, y to the n, and we took... So, that was... Let me make sure this is all right. Let me make sure this is all... Okay. X to the 5th, y to the 3rd, minus 4xy to the 4th, 2y to the 5th, blah, 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 blah. Great. So, when I multiply that through, I get x to the 5 plus m, y to the m plus 3, minus 4, x to the m plus 1, cool, y to the m plus 4, great. And then on this one, I get 2 x to the m, y to the n plus 5, 3x to the 4 plus m, y to the 4 plus n. I take derivatives with respect to x. That should pull this down. 5 plus m, x to the 4 plus n, y to the n plus 3, cool. Minus 4m, yeah, here's our issue. There's a minus on this. Oh, fuck, we fucked up, dude.
You gotta get in the hospital now.
Oh, no, we're fucked up, dude. We fucked up. I did pull a negative. God damn it. Okay, sorry. This is minus. Thank you. Yeah, okay. When do you think AI will take over the math industry? I don't think it'll take over the math industry ever. It'll take over, like, I mean, like, boring shit. Yeah, sure. Wait, I need to, let me just redo this, because I'm already getting confused. Yeah, so I think if you're trying to just be like a quant, if you're just, again, and I feel kind of bad because, yes, years ago when kids were asking me what to do, I told them to learn to code. I still stand behind that. I still think you should learn to code. But if you have a computer science degree and you didn't do anything else outside of just learning how to code, yes, you're kind of fucked. Because coding is getting taken over by, like, vibe coding and AI, Cursor, Replit, all these whatevers. That was already kind of going that way anyways because, honestly, they just outsource all the coding to India regardless. So sometimes it becomes like, what's cheaper, AI or just like Rashed in like fucking Hyderabad or something. But if you went into a computer science degree, you learned how to code, and from that you also took an interest in, let's say, algorithms, quantum computing, or like other cool things, like topics that build off of coding, then you're okay, because those things aren't getting replaced by AI. Immigrants are cheap. Well, not anymore, because they put a big price tag on the H-1B visas. They used to be really cheap. Okay, this is the minus sign I forgot. I make mistakes too. I'm human. Yeah, no, AI is great. No, and it's okay to use AI to learn. I'm a huge supporter of AI. I think AI is awesome. I use it live on the stream here all the time, guys, to like check questions. You watch me do it. It's totally okay. I think as long as you're being responsible and realizing that, oh, I actually have to at least do the work. I always make people will hear me make this illusion again and again because I love the gym. We have forklifts, right? We have mechanical devices that can lift really heavy things. We don't take those things to the gym and make them lift weights because that doesn't make you a stronger human. So if you're using AI to just lift the weights, if you're using AI to just do the problems, you're not going to learn anything. You're not going to build any cognitive skills. And when you get out of college, you're going to be shit out of luck with a job. But if you use AI to like improve your learning, so in the same way, if you were to use a machine to maybe spot you every time you were like failing on bench press so that you could lift more on bench press, then you would get stronger and you would get smarter. So yeah, I think there's cool things. Anyways, all right, let's multiply this by 4. I think this is what it is. Okay, 4m minus 12n is equal to 28. Minus 4m minus 2n is equal to 14. Let's add these together. This looks better. Minus 14n is equal to 42. 42 is the original 6, 7. N is equal to -3. Cool.
My man.
Oof, that hurts, right? Yeah. It definitely does save time. Yeah. And then if n equals -3, we can just plug that back into here. So I get -4m plus 6 is equal to 14. -4m is equal to 8. So then m is equal to -2. Cool. So my integrating factor, u, is equal to x to the m. So x to the -2, n to the -3. Nice. Okay. And then once you have that, you can plug that back into here. And then I think it's pretty straightforward to solve the equation. So here, we found the integrating factor, Kev, if you're still here. I'm going to leave maybe this as an exercise to do later to actually solve the differential equation, but this was like the hardest part, I think. Because then it's just, I think what you do is you just find, you just match like df dy with dn du, I think is what you do. Or dn dx maybe. Yeah. Okay, cool. Great question. Love it. AI cannot replace plumbing. True.
Well done. Well done.
Bobby asks a great question. How are you funding this server? Okay, so this server started around 2021, and I originally took a bunch of like loans and grants out during COVID from the U.S. government to kind of throw at this as like a nonprofit. I also dumped a lot of my own cash into it, just to like get it off the ground. As of right now, I mean, if you're on Twitch, you can see we've raised like $600. So we do get a lot of like private donations that come in that help out. I make some money off of TikTok videos I create, like the tutorials and stuff. I think I've made a couple $100 there. And we're hopefully getting approved for like AdSense revenue next week. So I'm hoping this is cash flow positive in the next year or so. It has definitely not been cash flow positive for the last 4 years, but it takes money to make money. It takes money to like build things. Also, this is a nonprofit. I don't get paid. I don't get anything from this, but it's, and also, yeah, people started donating super chats on YouTube. You guys are awesome as well. Yeah, but it's a charity, so it doesn't really make money. It would be nice if it could at least maybe offset some of the time I have to spend to tutor kids for money, to make money. But yeah. So I'm definitely losing more money than I earned. Yeah, 100%. Yeah. This definitely cost me money. But it's all for you guys. But yeah, grants and donations can help. I'm applying to one for OpenAI that's due tonight at midnight. So if one of those hits, that could be nice. But I think with any sort of project, you have to put a lot in, and then eventually it works itself out. Yeah, thank you, Dr. Lord. You guys are great. Yeah, that's cool. Okay, cool. So let's see. Whose question did we do there? Let's go to the stats. I need to see the stats. Yeah, the students will come. Well, I mean, the students are already here.
It was mine. Totally mine. It was all mine.
Yeah, what's up, Justin? How you doing, Justin?
I'm doing good.
Nice. How's life?
Doing great.
Amazing.
Good. Yeah.
What is this? Is like the equivalent of like the Gen Z stare for like conversation, dude. This is like the most monotone shit I've ever heard, dude. What's going on?
What?
Oh man.
So I'm playing. I can't believe you say this. Fortnite.
You're
right
playing
now.
Fortnite.
Yeah.
I do need to play this with you. I do need to play some Fortnite, honestly.
I'm playing the Demon Rush mode.
Oh, nice.
Yeah.
Okay. Oh fuck! I got rid of the wrong question. Damn it! I got rid of Grud Dogs. Okay, one sec. Let me help some people here. We did Maria's. Random user said he had to leave. Thanks for being such a good guy, Dr. Gull. You're welcome, guys. That's cool. Yeah, and you know, we do get a lot of support. I used to spend a lot more of my own money on this. I'd say now I probably spend like $100-200 a month. So it's not that bad. I mean, that's like one night out in Los Angeles. I just like got to cut back on like drinking like one night or something. It's not the worst. But every once in a while, we do get like someone random on PayPal who will just donate like $1,000, which is great because then that just like pays all the server costs, pays all the prizes for like 6 months. But I'm trying to expand this bigger, which means I need more funding. So we're trying to do that. We'll get there. Let me see. Is Lucas, are you still here? Lucas, this was your question. Oh, dude, thank you, dude. That's funny. Hey, son. Where do you send questions? You know where to do this, dude. Well, I actually haven't. Yeah, here you go. Submit. That's where you add them. Sorry. Okay. All right. Gotta skip muscle milk for the week. Yeah. Gotta eat some ramen. Yeah, you're good, Bobby. Let me see. Is Lucas, you still around for me to do this one? Based and dedicated free to big. Yeah, thanks, dude. So, like, my eventual plan, and this has always been my plan, because, like, there's only so many of me, and I don't scale, right? We can't clone me, right? My eventual plan is to have kind of more of a network of people like me, and then we have enough funding to basically pay for their time for them to also kind of host their own free tutoring and stuff. And I was thinking about this today. I think a big barrier to entry, it isn't just, you know, who's a good teacher, who's charismatic, who's great, who wants to like do this. There's also a lot of costs involved, just with like getting it set up. So, for instance, if you want to see like what my setup is for this, it's pretty wild. Here we go. This is my setup that I use in order to stream. So I got was it 5 monitors to do this, because I got OBS, like Discord, I got something else over here, then I got this, and I got the prompter. So this is a work in progress over like the last 5 years as well. And I think it'd be kind of difficult for me to tell someone who wants to start streaming math and science, be like, hey, just buy like $3,000 worth of computer shit and just start streaming. Right? What? So I was like, it would be cool if I had funding to kind of set up like a space, maybe start in Los Angeles, because that's where I'm based, and have people who want to tutor come in and just like sit down at like the rig, like the system, and then be like, cool, you're gonna like go over chemistry for people today, and then just like have that happen. Yeah, wouldn't it be cool? It's cool now. Also, yeah. We already have kind of like a loose network of, math streamers that help out. I'm gonna drop some links. There's that math streamers. Yeah. That already do this, and we rate each other. We like send students to each other, and we try to like kind of fill out a calendar. So if you're thinking about streaming and you want to get involved, like please let me know. I'm more than happy to support up and coming people that want to also do this. Yeah. Okay. Zivanki says, please solve my centroids question. I left last time. That was like 2 days ago. Exactly. Yeah. All right. Where's my chat? No, that's. I gotta. Let me go through all the questions we have. We got a lot today. There we go. Okay. I don't see Lucas, so I'm gonna skip on that one. I think random user said he had to go to bed, so maybe I'll do Yadavir. Okay, let me see if I can do Yadavir's. Yes, exactly. Yeah, no, yeah. Obi's another example of like one of those streamers. Yeah, I agree with this too. All tides raise all ships. Totally agree. Yeah. I just need more people to stream. More people need to get into streaming and like donating their time for free, so that we can cover the earth or like cover the calendar with opportunities. All right, let's see if we can do this one. This looks a little tough, Yadavir. I'm glad you're here though. We're gonna test it out. Yeah, and also River, you don't need a professor degree to be able to help. We have people who just have undergrad degrees. Even if you're in high school and you were really motivated to teach, say, middle school, like early high school math, you could do it. You could be a streamer. You could do it. Yeah, that's cool. Yeah, Zimfonky, you can resend it, but I'm gonna warn you that the queue is already pretty long, and I might be running out of time because I have to go tutor students for money because I have to pay my rent. It sucks. All right, let's try to do this. Let alpha and beta be contained in the set of natural numbers be roots of the equation of this, where lambda over 2 comma lambda over 3 are not natural. Okay. If lambda assumes the minimum possible value, then this is equal to what? Okay. So we need to minimize lambda, right? This kind of looks like something I could factor. Yeah? Oh, and it says there's only 2 roots, right? Okay, whoa. Okay, watch. So x squared minus 70x plus lambda is equal to 0, right? If this factors into like x... So this would be x minus alpha, x minus beta, right? If I were to factor this out into 2 roots. That means I need something that multiplies to lambda but adds up to negative 70. Oh, sorry, I gotta reload the stream. We've been maximum timed. Yeah, you can. Yeah, we may use that as well. Let's do that as well. No, I agree with that. Let's maybe use that material as well. I'm just gonna write down things that we know. I lost my pen. There's my pen. Okay. So I know that alpha beta needs to be equal to gamma, and also that alpha plus beta needs to be equal to negative 70, right? For some reason they say lambda is not divisible by 2 or 3. I could solve it using... Yeah. And then it says lambda solves the minimal... Oh, wait a minute. I have this wrong. Sorry. In this form, alpha beta is equal to lambda. Okay, but this is it's weird. This is like minus alpha minus beta equals minus 80. Yeah, so alpha plus beta is equal to positive 70. Yeah, let's do what Joke said. Let's do it real quick. I'm gonna do that too. Let me just do the quadratic equation. So x is equal to negative 70 plus or minus the square root of 70 squared minus 4 lambda all over 2. Right? So we get x is equal to negative 35 plus or minus the square root of, what was it, 4900 minus 4 lambda all over 2. Which one? I can put that like over 4. Does that make life nicer? And I guess the roots... It does? What does it do? What's 4900 over 4? I'm gonna go find it. $4,900 over 4. Oh, it's 1225. Ooh, love that. So square root of 1225 minus lambda. Not the TI emulator. You like the gold one? It's pretty sick, right? It's the TI-84 Gold Edition, dude. Okay, this is equal to x. Yes. And if lambda assumes the minimum possible value. Okay, so the lowest value. Sorry, what am I saying? The lowest value lambda can be is it 1225? Oh no, it could be 0. Wait, can't lambda just be like fucking whatever then? Oh, the roots have to be natural numbers. Oh. Lamau. What's up, 9? Oh, see, sorry, negative 35. Thank you. Good catch. Ooh. Also, 1225 is equal to 35 squared. Ooh, maybe that does help. Okay, so wait. So I have is equal to negative 35 plus or minus the square root of 35 squared minus lambda. Oh, okay. Oh, okay. So lambda is the smallest value. Lambda assumes the minimal possible value so that sorry, our natural numbers can't be negative. Is that the rule? Positive. Yeah, cool. All right. So that tells me something right away, right? Yeah, thank you. Okay. So if you have negative 35 being added and subtracted by something, right? The lowest this can be is 35. Right? Do the discriminant now? Right, yeah. So 35 squared minus lambda has to be greater than 0. So lambda has to be less than 35 squared. Yeah. Correct? Okay. But then also the roots have to be positive. Right? Here's the thing. I don't think I can get 2 positive roots. One of them is gonna have to be negative. Oh, wait. Negative b. Sorry, it's already negative 70. Okay. This is positive. Sorry. Good. Good. All right, I fucked up too. All right, there we go. It happens. It happens. It happens. It happens. Okay. Oh, very cool. So, yeah. If this is equal to 35, so this is very cool, actually. So I need 35 plus the square root of 35 squared minus lambda to be greater than 0. And I also need 35 minus the square root of 35 squared minus lambda to be greater than 0. Correct? We agree with that? So then I do functions, yes. 35 squared minus lambda. Square both sides, so 35 squared has to be less than 35 squared minus lambda. So lambda has to be greater than 2 times 35 squared, right? Or lambda has to be greater than 2 times 35 squared. And then from this one, what? You get 35 squared minus lambda has to be greater than 35. And it can be written as a difference of squares. Okay, sorry. Lambda is greater than 0. Sorry. Where did I mess up? Sorry. Oh, you are so right. Yep. Thank you. Lambda has to be greater than 0. Duh. Okay, yeah, sorry. Yep. Minus. You get, 0 is less than negative lambda. So then negative lambda is greater than 0. Okay, cool. Thank you. Thank you, mathematic fanatic. How screwed am I? Oh, smart. I hope you're not that screwed, dude. Dr. L, what's up, dude? 1729 is equal to 9 cubed plus 10 cubed, which is equal to 1 cubed plus 12 cubed. Where is this 1729 going to help me? Okay, so, yep, duh. So lambda has to be greater than 0. What's the top end on it, though? I feel like the top end comes from this. Right? So, the square root of 35 squared minus lambda has to be greater than negative 35. Square both sides. 35 squared. That doesn't really help me, does it? Ugh. This doesn't really help me. What are we missing here, chat? Chat, we're missing something here. Oh. I think... Yeah. I don't think the quadratic formula is really helping us out here. Okay. This was a cool departure. Let's go with this. I'm going to start with this. 5 is the smallest value. I'm curious how you got that. Okay. Joke says... And neither of them have 2 or 5 in it. Okay. He says, why don't you just replace x with either alpha or beta and substitute the rest into the formula for about? Okay. I see. So it's not divisible by 2. It's not divisible by 3. Okay. I think I like this. Let's just do this. Alphas and betas that add up to 70, but aren't divisible by 2 or 3. Right? So, if it's not divisible by 2, it has to be odd, right? So, I need 2 odd numbers. So, I mean, let's just spitball some, right? Okay, so, if I have 1 plus 69... oh, this fails. Right? Because I can't divide by... 69 divided by 3 is 33, is 23, right? I can't do 3... Okay, so what about 5? So 5 plus 65 69, nice.
Nice.
Yeah. No, alpha and beta have restrictions. Alpha and beta have to add up to 70. And they have to be natural numbers, which means they have to be positive. Also, alpha beta has to be equal to lambda. So if we're trying to minimize lambda here, right? I want to find like the smallest. I want one of them to be the smallest numbers, right? Because, I mean, let's just show an example here, right? Let's say like alpha plus beta was equal to 10. So you could have like 1 and 9, right? So this would be equal to 9. 2 and 8, that would be equal to 16. 3 and 7 would equal to 21. 4 and 4 would be equal to 16. Sorry, 4 and 6, sorry, would equal to 24. 5 and 5 would equal to 25. So you want one of the numbers in the pairs to be the smallest number it can. What's the level of difficulty? This is probably college level. Yes, exactly. Mathematic Fanatic is correct. So the closer the two numbers are to each other, the bigger that multiple is. As we see this just from like 10. So I want one of these to be as low as possible. Okay, so I think Jeff is right. I think alpha has to be 5. Because 5 plus 65 is equal to 70, right? And then 65 is not divisible by 2. 65 is not divisible by 3 either. It's kind of like an well, I mean, the first part's kind of like an optimization. Okay, so we've got our alpha and our beta. So alpha is equal to 5. Beta is equal to 65, right? And then alpha beta is equal to lambda. Yeah. This is a competition level question, probably. So, what's that, 325? So then, oh, let's just plug this shit in, right? Okay, so square root of 5 minus 1, which is 4, plus the square root of 64. Oh, beautiful. All times 360, right? Lambda plus 5. All over 60. Oh, look at this. This is beautiful. 360 and 60 just gets me 6. This is 2 plus 8. So your final answer is, I believe, 60. Do we agree, chat? We agree at 60? I could also throw this in the chat GPT real quick. Zaldu says it's wrong? Excuse me? Agree. Says nice? Nice, I'm going to call it. If we really want to, here, I'll throw it in the chat GPT. I'm sure it can just get it real quick.
Well done! Well done!
It's 18 over 7 square root of 17. False.
No.
60 is the answer. Nice. Thank you, Yadavir. That was a cool question. Really cool. Yeah, I threw it at ChatGPT. We'll see what it says. I'm pretty sure. Okay, the answer key says 60. I believe the answer key. Yeah, it's a really cool problem. Honestly, like, this scared me at first. I was like, this is gonna fucking hurt, dude. But then this stuff made it nice. We had to remember, this is kind of like Vietta's formula, I think, for the roots and stuff. And then this, Jeff made the good observation that divisible by 2, right, means can't be even. Divisible by 3 starts really limiting. And then Mathematic Fanatic came up with a good thing that if you want it to be minimized, you need the numbers that add up to be very far away from each other so that they multiply to a small value. Yeah, no, Yadavir says it's 60. I believe in Yadavir. I don't know who... Zalodu is just, I think, trolling. Alright, nice. Let's mark that off. So, that was... Let me clear 5. Let me clear 6. And then let me clear 5. Okay, I think we had another one from Grudog. This is kind of a fun one. Dr. Gold, are you a fan of Euler? He's my idol. I think he's a pretty cool guy. Doesn't afraid of anything. If you want to submit things, there you go. That's it. That's the link. All right, let's see. I think this is a limits question, which I believe is going to be pretty similar to what we did with L'Hopital's rule, yeah? This isn't too bad. So here, River, watch. This is a L'Hopital's rule question, right? The OG Smirnoff says W Euler. Nice. I'm more of a Poisson guy. Okay, let's see. In order to do this, so I can kind of look at the powers. So the highest effective power here is x to the third. The highest effective power here is the square root of x to the fifth, which is really the square root of x to the 5/2. So it's really the square root of x to the 2.5. So because this power is higher than this power, I think it goes to infinity, right? Yeah, Jeff, right? Yeah. That's the proper way to do it. I mean, not the proper way. That's the quick way to do it. The proper way to do this is to take derivatives. But I fear this might just get ugly. Yeah, as soon as a radical is garbage, yeah. Or you're obsessed. There's nothing wrong with being obsessed with math. Math is great. I mean, there are worse things to be obsessed by, you know. Definitely in this world. There are people that, like, just eat butter all day. Have you seen these people? They just eat, like, a whole stick of butter. Like, they just, like, dip it in peanut butter and they just start eat. I think her name is Butter Girl or something. Yeah. So, yeah, don't be obsessed with eating butter. Colton, I just threw up. I'm sorry, Colton. Colton, if you want to ask a question to go over, we can do it. You love this channel? Thank you, dude. Oh, very... ooh. Vladko has a very... Vladko, what's up, Vladko? He has a very good point here, but negative infinity to the third is negative infinity. So the question is whether this approach is negative infinity or positive infinity. I think that is a valid question. Okay. Because I forget what happens when you have negative infinity to, like, the 2.5. Cool. I like that equation. That's a good one, John. John's got a good summation one, John. It looks like summations. Yeah. Also, you don't have to have other passions. I mean, it helps, but you don't have to. Yeah. Okay. Yes, I agree. Well, for negative infinity, right, this becomes positive. Okay, I think we do have to do L'Hopital's rule here. La Hospital. We're going to the hospital, dude. I think we have to do L'Hopital's. Let's just do it. Because I think I do get infinity over infinity, just to start with. I'm just going to assume I do. So derivative of the top is going to be negative 7 plus 30x squared. This is going to be a chain rule. So the derivative of 5 plus 3x minus 9x to the fifth, all to the 1/2. But there's a minus sign here, though. It's minus negative infinity. So it becomes positive. Yeah, musical instruments are dope, too. Okay. So that's going to be 1/2. 5 plus 3x minus 9x to the fifth, right? All to the negative 1/2. And then it's going to be times the derivative of what's inside, which is just 3 minus 45x to the fourth, right? So this, which the minus 1/2 puts it on the bottom. So we can take this, put it underneath here. 1/2, put a 2 from here. This goes away. Okay, cool. Yeah, because it's a minus sign, yeah? Right? Okay. So now we have this beautiful thing that we're going to put underneath here. Which, I believe now this thing is going to come on the top then, right? It's kind of like try to keep things organized. Yeah? Right, dividing by fractions, flip the second, multiply. How do you get better tutoring for math? Tune into the stream. Come get help. We got you. Okay. So let's see what I got. So this is going to be equal to Negative 14 plus 60x squared. Okay, sorry, let me just write this. Well, okay, so we got 60x squared minus 14 times the square root of 5 plus 3x minus 9x to the 5th, right? All over 3 minus 45x to the 4th. Oh, you want to improve as a tutor. Oh, practice, dude. Yeah. Gordon Feetman? That's a dope name, by the way. What? Gordon Feetman? I think this is maybe calculus is what this is, 214. Wake up, Mr. Freeman. Wake up and smell the ashes. I'm a big Half-Life fan. Yeah, the best way is to practice. Again, you can do what I'm doing. Just stream free tutoring. Like, no one's gonna get mad if I do it wrong, because it's free. Yeah. I'm waiting for Half-Life 3, dude. When? I still have to play Half-Life Alyx. I have it bought. I just never played it. I'm talking about the VR one. Okay. So limit as x approaches negative infinity. Okay, I think we're okay here saying it's positive infinity, no? Wait, fuck. Wait a minute. Yes, yes. Okay, because watch. Well. Oh, you get motion sickness? Yeah, the VR stuff is weird. Just divide both sides by x to the 4th. I kind of like that, Dylan. I vibe with that, Dylan. That's great. Yeah, let's fucking do it. I'm cool. I can definitely do implicit differentiation. Yeah, that's fine. Okay, yeah, let's do it. I'm cool with it. We can hang. So that's going to be 60 over x squared minus 14 over x to the 4th. Times, well... do I have to bring this inside the square root now? Yeah. Now, the issue is these two things are multiplying each other, right? If I bring it out here, this looks like 0, right? But then this is going to beat that out. Right? Oh, wait a minute. No, this is automatically going to win. This, fuck. No, it doesn't. I don't think I want to divide by x to the 4th. Well, maybe, yeah, I do, because I want this to be 1. Okay. I'm thinking about this. Yeah, you're saying we could have done this and just divided by x to the 4th? I think that would have been a better idea. Let's do that. Let's do that before the L'Hopital rule. Okay. But I think you want to divide by x to the 3rd. Because if I divide by x to the 4th, this goes to 0. You want to divide by x to the 10th. Sure. So 1 over x to the 10th. No. I think x to the 5th is what you want, right? X to the 5 halves. Yeah, let's do that. Okay, one second. Okay. Let's divide by 1 over x to the 5 halves. And then this is dividing by basically, right, the square root of x to the 5th. Cool? So I get 1 over x to the 5 halves minus 7 over x to the 3 halves. Right? Because it's 1 minus 5 halves is 3 halves. Plus 10x to the 1 half. Yeah. Jeff is right. Jeff, see, you are right a lot of the times, Jeff. Jeff's great. Thank you, Jeff. Jeff, when are we gonna get you to stream, dude? That's what I'm asking for. I want it to happen. The Jeff stream. plus 3 over x to the 4th minus 9 over x to the 5th. No, minus just 9, sorry. Beautiful. Okay. Cool. Now take the limit as x approaches negative infinity. Oh, but we're kind of fucked here. I can't take the square root of a negative number. Damn it. Oh no. I can't take the square root of a negative number. Oh, drum set. Nice, dude. Paradiddles. Yeah, I remember paradiddles when I was doing snare. Shit. Divide by -1. No, you can't do that. I don't want to leave a square root of a negative. I mean, sure, maybe. Okay, whatever. This goes to 0. This goes to 0. But you see the issue here is that I have plus 10 to the square root of negative infinity over the square root of -9. Okay, do math people, don't get mad at me. Is this okay? Infinity over 9, so it's just equal to infinity. Oh yeah, hustler, be nice. It's okay. Factor out the square root. Yeah, fuck it. Yeah. Divide by -x to the -5/2. Okay, I think the answer is just that. Let me see. Let's throw this at ChatGPT real quick. I'm curious. Harville says no. You can't do that. Well, you know what? Let's see what the AI overlords say.
That is one big pile of shit.
I don't know everything. No, I definitely don't know everything. I have a PhD in physics, so my knowledge of math eventually tops out, especially when people start giving me like really fucking hard questions. I'm human, dude. Everyone's human. Okay, they divided by 5 to the half, 1/2 as well. Okay, so this is the argument. They say we're taking the principal branch of the square root, so we basically replace it with an absolute value. Preeti says you can multiply with a complex I. I guess you could. Yeah, okay. You have a midterm on this soon? Yeah. Can't you just use the sandwich theorem? No, the squeeze theorem? Yeah. The squeeze theorem? What's the sandwich theorem? Yeah, no, it's pretty decent with math though, especially with this stuff. Okay. So wait a minute. I think what I heard was let's multiply this by I. We got to here, right? So you wanted me to multiply by the square root of -1? Is that right? On both sides? Yeah, okay, cool. So then that's 10. I don't think that messes up anything here, right guys? Like these are still just gonna go to 0. Oh, your comment got filtered? Oh, why? Alright, I don't know. Okay. So this is -x to the 1/2 over, I think these go away as well, right? And then we got the square root of 9. Keep it as I for now. So you want me to keep this as I? Okay, fine. So this is 10i, right? Is that what we're going to say? What was the question? Here's the question. Haravel, if you want it. This is calculus. This is pretty hard calculus, though, honestly. This is not typically this difficult. This is someone trying to fuck with me. It's just okay. I appreciate getting fucked with. Okay. All right. So now this is the limit as x approaches negative infinity, though, right? We still got that. This is not pre-calculus. No. This is calculus for sure, I think. It is high school calculus, yeah. Okay. So is that 10 times I times the square root of negative infinity all over 3, right? But the square root of negative infinity, I believe, is the same thing as I square root of infinity. We agree with that? I see. This goes away. This becomes -1. You get... Well, sorry, this doesn't go away. This just becomes negative infinity. Yes. Okay, cool. Answer's negative infinity. I believe it. I'll take it.
Well done.
It's kind of a weird one, honestly, that question. Okay. All right, I got time for like 1 or 2 more. So yeah, if you're just joining us from YouTube, TikTok, whatever places, please feel free, hit that like button, hit that comment button, hit that follow, subscribe, whatever. It helps the algorithm like pump stuff up. We're a nonprofit and we do live streaming 5 days a week to help students with math and science. Also, if you want to join our Discord and you want to earn like video game gift cards, it's real. We have a whole system for if you're doing well in school or, you know, any sort of other activities, playing an instrument, doing well in sports. We're a nonprofit. We give out gift cards for doing well and stuff. So join the Discord, learn more. And then there's also a website, that actualdiscord.com/submit, and that's where you can find our streaming schedule. So if you click here on streaming schedule, because I am going to have to end the stream in 10 minutes. This has our calendar of all the days that we stream, and all the times we stream, and all the times our friends stream, because I'm not the only person that does this. There are other people that do this. So welcome. The algorithm brought you to the right place. You got her just in time. Nice. Yeah, okay, here we go. All right, I'm going to try to do this one. Show that the summation of xi minus x bar yi is equal to the summation of xi minus x bar yi minus y bar, which is equal to the summation of xi yi minus y bar. I'm confused with what's happening here, but there's a lot of stuff going on. First time viewer, welcome, dude.
Yeah.
Algorithm sent me. Algorithm smart. Yeah, Soulful, this was yours, by the way. Let me just paste yours in, just so we can also see yours. Because I have 10 minutes. I have like 8 minutes, actually, so. Don't stress, you're good. How does this work, by the way? I can distribute this in, right? This is the same thing as the summation I equals 1 to n of xi yi minus x bar yi. Yeah, I think it's the arithmetic mean, right? So, the summation of I equals 1 to n of x bar, isn't that the same thing? Wait, you're just adding the average a bunch of times? Isn't that the summation from I equals 1 to n of x? Isn't this like kind of the definition? Right? Yeah, right, Sid? Yeah, okay, cool. Yeah, we did this earlier. You know, this is so cool. Because it's the same thing. Literally, like, I'm going to go so far back to during the stream when we did this as well. We did, was it this? No, it was this question. So one of our students asked this question. Very, very simple, just like, what's an arithmetic sum? And I showed that, like, oh, you know, it's the same thing as taking the average times the amount of terms that are there. Oh, it's n times x bar. Yeah, no, so, yeah, the arithmetic mean, yeah, so this is the same thing as nx bar. Yeah, elementary calculus, right? And nx bar, this is the same thing for an arithmetic sum. This is how you find the sum of an arithmetic series. Correct. Okay, cool. All right, whatever. Fuck. All right. Okay. So can I just like switch the orders of it? How do you get the y bar in there though? Oh, I see. 1 sec. Yeah, right. Okay, cool. So because this is a constant, right? I can kind of just pull that out, right? Isn't that just nx bar? Sorry, let me make sure I'm doing... it's all this fucking algebra shit. Okay. Wow, and we got a raid from Ivan Neo. What's up, dude? Okay. So I think it's this. This. And then... multiply the second expression. Open it up. Yep. And then this is the same thing as ny bar, right? Right? Oh, it's just y bar then. No. Yeah. Conscious Pirate, what's up, dude? Globus the Elder, yo, what's up, Globus? I love you, Globus. How's the crypto space going, dude? Okay, what am I eventually trying to prove here? I'm trying to get to here, maybe. You know, Josh has a question. What's up, Josh? Oh, my brain's hurting at this point. We've been streaming for almost 3 hours straight now. I was liking the Sigma, but not anymore. I agree.
Nice.
Oh, okay. The second one. Okay, one second. Thank you. And this was x bar yi. I see. And you're saying expand this as xi minus x bar yi minus y bar. Because that comes from this. Is equal to this. Oh, okay. I see what you're saying. And then this is the same thing as yi minus y bar? No, the right-hand side. Oh, okay. Wait. One sec. You're talking about this right-hand side. Got you. Okay. One sec. The one before that. Oh, you want to expand this one? Oh, okay, fine. We can do that too. Oh, man. This is xi, yi, minus... I'm just gonna write sigmas. I'm not writing all the fucking things all the time. Basically, the idea is to look at the expression on the right side of the first equality and try to take it to the left side. You're okay. It might. Let's see. Okay, so xi iy minus xi y bar, right? Minus x bar yi plus x bar y bar. Right? That's what we said this is equal to? Yeah. Also, yeah. No, I do have to go in like 30 seconds. Okay, sorry. I have other students I have to teach. I know we just got a ton of people in the stream. I'm really sorry, but I have been streaming for 3 hours. Suffle. Can we go over this equation with you tomorrow? Or actually, I might have to open a stream up tomorrow for this because, yeah, I do have a lot of people that have questions. But, yeah, okay. All right, I need to go. But thank you again. Let me do the closing credits. All right. Thank you, everyone, for coming to the Actual Education Office Hours today. If you guys just found us at the last minute here, I apologize I didn't have more time to go through your questions. We've already been on for 3 hours. But please, make sure, like, subscribe, all that fun stuff. Turn on notifications. We have a website here. It's www.actualdiscord.com/submit. And if you click here on the streaming schedule, you can then see all the times that we stream. So you can see we kind of went really far after time today. And if you have a question you want us to go over on the stream, you can drag and drop the screenshot into here, enter your username, hit upload. It'll work. Join our Discord if you want to talk to us more, and if you want to earn prizes, we have all that stuff as well. Cool stream. I'll be back. I'm glad. All right. So what I'm gonna do is, because I have so many people who raided me today, we're gonna go raid somebody else. Keep the love going. You're very welcome, OG Smirnoff. Thank you guys for being here. I appreciate it. We got Penn Center. What's Penn Center doing? Look inside. Oh, let's go to these people. I love these people. So this is Ask a Scientist Gaming. So they're a really cool stream. It's this guy out in Florida where he interviews other like professors and stuff, and they play video games while they answer user questions. So if you're not yet watching us on Twitch and you found us on YouTube, again, go to the website, click watch live on Twitch, and then you'll get pulled into this stream that another awesome person is doing with math and science stuff. So let's go start a raid. Say hi to them. Okay. We will see you guys tomorrow. Enjoy the rest of your Wednesday. Thank you so much for coming by. Peace.